World Empires Series Part 11, The Scientific Revolution and the Age of Enlightenment, Chapters 71-78, 1543-1800 AD. Introduction. The Reformation has shattered the unity of Western Christendom. The printing press has made ideas unstoppable. And now a different kind of revolution is beginning, not political or religious but intellectual. For the first time in human history, thinkers are developing a systematic method for distinguishing truth from falsehood, one based not on authority, not on tradition, not on revelation, but on observation and experiment. This is the scientific revolution, and it will change everything. Chapter 71, The Copernican Revolution. In 1543, a Polish canon named Nicolaus Copernicus published a book called De Revolutionibus Orbium Celestium, on the revolutions of the celestial spheres. He was receiving the first copy from his printer when he lay dying. The book argued that the sun, not the earth, was the center of the cosmos. This was not merely a technical astronomical correction. It was a profound challenge to the integrated worldview of medieval Christendom, which had built on Ptolemy's geocentric model and Aristotle's physics, a picture of the universe in which Earth, and therefore humanity, stood at the center of God's creation. Moving the Earth from that center had theological implications that would take decades to fully surface. Copernicus was careful, perhaps deliberately cautious, and the book initially attracted more scholarly than ecclesiastical attention. The shock took time to land. Chapter 72, Galileo, Kepler and the New Astronomy. Johannes Kepler provided what Copernicus had lacked, the mathematical proof. Working from the extraordinarily precise observational data of the Danish astronomer Tycho Brahe, Kepler showed that planets move not in perfect circles but in ellipses. This was as revolutionary as heliocentrism itself. It required abandoning 15 centuries of assumption that the heavens, being perfect, must move in the most perfect of shapes, the circle. Galileo Galilei built a telescope in 1609 and turned it to the sky. What he found was devastating to the old cosmology: mountains on the moon, proving it was not a perfect smooth sphere; 4 moons orbiting Jupiter, proving that not everything in the cosmos orbited Earth; the phases of Venus, which could only be explained by Venus orbiting the Sun. Each discovery attacked Aristotelian cosmology directly. The Church's response was complex. In 1616, the Inquisition declared heliocentrism formally heretical and ordered Galileo to stop advocating it. He largely complied for a while. Then in 1632, he published his dialogue comparing the two chief world systems, which rather obviously made the geocentric position look absurd. He was tried by the Inquisition in 1633, threatened with torture, and forced to recant on his knees. He spent the rest of his life under house arrest. Legend says that as he rose from his knees after recanting, he muttered, "And yet it moves." The legend almost certainly isn't true. But the sentiment is exactly right. Chapters 73 and 74. Bacon, Descartes and Newton. Francis Bacon articulated the philosophical foundation of the scientific revolution. In his Novum Organum of 1620, he argued that knowledge must be built from the bottom up, from specific observations to general principles, rather than deduced from assumed axioms in the Aristotelian manner. His taxonomy of the 4 idols, the systematic errors that distort human thinking, was a remarkable early account of cognitive bias. Descartes went in the opposite methodological direction, radical doubt. In his Meditations, he stripped away everything that could possibly be questioned, until he arrived at the one thing he could not doubt, that he was thinking. I think, therefore I am. From this single certain starting point, he attempted to rebuild knowledge. His mathematical approach to philosophy and his development of analytic geometry made him one of the founders of the modern scientific tradition. And then came Newton. Isaac Newton's Principia Mathematica of 1687 is, by common scientific consent, the most important scientific book ever written. In it, Newton demonstrated that the same force that causes an apple to fall also governs the orbit of the moon. Gravity was universal and followed a precise mathematical law, the inverse square law. The planets, the tides, falling bodies, ballistic trajectories, all were governed by Newton's 3 laws of motion and his law of universal gravitation. Newton also invented calculus, independently of Leibniz and simultaneously, leading to one of science's bitterest priority disputes. His work in optics, showing that white light is composed of all colors, transformed our understanding of light. And his work implied a clockwork universe, deterministic, mechanically precise, governed by discoverable laws. God had set it in motion, the machine ran itself. It was a short step from Newton's deist universe to the entirely godless universe of later thinkers. Chapters 75 through 77, The Enlightenment and the Revolutions. The Enlightenment was the great intellectual movement of the 18th century, the attempt to apply the methods and the confidence of the scientific revolution to every domain of human life: politics, morality, religion, economics, and education. Its rallying cry came from the philosopher Immanuel Kant: dare to know. Have the courage to use your own understanding. Its enemies were superstition, tradition, and arbitrary authority. Its heroes were reason, liberty, and progress. John Locke provided the political philosophy: government derives its just powers from the consent of the governed, and the people have a right to revolution when government violates natural rights. Voltaire provided the wit and the outrage. His pen was the most lethal weapon of the age, and his target was the Catholic Church and its alliance with political oppression. Montesquieu worked out the institutional framework, the separation of executive, legislative, and judicial powers as the guarantor of liberty. Rousseau contributed the most explosive idea: popular sovereignty, the general will of the people as the only legitimate basis for government. The American Revolution of 1776 was the Enlightenment put into practice: Locke's natural rights in the Declaration of Independence, Montesquieu's separation of powers in the Constitution, religious liberty in the First Amendment. The French Revolution of 1789 went further and paid a higher price: liberty, equality, fraternity, but also the guillotine. The Terror of 1793 to 1794, when Robespierre used the language of the General will to justify 17,000 executions, demonstrated the darker possibilities lurking in Enlightenment idealism. The revolution ended in the dictatorship of Napoleon Bonaparte, who exported revolutionary ideas across Europe at the point of a bayonet, and who redrew the map of the continent more completely than any ruler since Charlemagne. End of Part 11.